that's not helpful. What about now? Am I still silent? Can you hear me? Can everybody hear me okay? Yes, no, maybe. Yeah, we can hear me. Wicked. All right. How's everybody doing? What's everybody been up to apart from all of the study that I'm sure that you've been getting done? I'm a bit quiet. All right, I will try to move the mic a little bit so I'm a bit louder. So mainly mainly watching things. That is fair enough. You did 2.5 hours of work today. Well done, Buzzkill. Went for a walk, cycling, basketball. Perfect. You guys are so dedicated to your studies. Cycling. Lots of exercise happening. It is quite tricky to be getting exercise done in these stay inside kind of times. You need motivation. Hopefully I can provide some of that. All right, let's get started with some covalent bonding questions. On your exercise bike, that is smart. I do not have one of those. Maybe I should find someone. Find one. Brain, words. All right, sharing the PowerPoint with you. So you should be able to find the booklet in the description so that you can write in your answers. So please open that up so you can be sort of following along. So just in case anybody's new, the deal with this is that we're going to go through sort of questions one by one or two, and then I'm going to give you guys some time to sort of come up with your own answers. So have some paper in front of you or a tablet to write on. And then once we've had a little while to answer them, I will be sort of going through the answers and you'll have a chance to answer any questions. So that's what we'll be doing. All right, without further ado. Okay, can we all see the presentation okay? Has it popped up for everybody? Yes, no, maybe. Yeah? Okay, perfect. All right, so at the end of this, you guys will also be getting a nice coupon code for SnapRevise Ultimate or Pro or the basic package, whichever package, but there is a nice discount code. All right, so our first question reads, in 2009, new material called graphene was discovered. The diagram shows part of a model of the structure of graphene. Each carbon atom is bonded to 3 other carbon atoms and to 1 hydrogen. So the first question is, deduce the crystal structure shown by graphene. So what kind of structure do we have for graphene? So you've got about a minute to come up with an answer. Never Drink and Derive. I love your YouTube name. That is fabulous. Okay, we seem to have quite a few answers in there, and I can't see, I've seen mostly correct answers. So the answer that we're going for is giant covalent, or giant molecular, or macromolecular. So if you've said just covalent, that wasn't enough to get you the mark. You also can't just say giant. So we want a giant covalent or macromolecular. What is giant covalent? Giant covalent is basically the opposite of a simple molecule. So anything that has like a massive lattice, like this one, that sort of goes on and on for hundreds, thousands, even hundreds of thousands of molecules long, that's macromolecular or giant covalent. Things that only have like a few between like 2 atoms in a molecule, or maybe even up to like 20 kind of simple molecules. Anything bigger is giant covalent, really. Okay, well done, everybody. Mostly we got that correct. Okay, so the next question says, state how 2 carbon atoms form a carbon-carbon bond in graphene. So you got another minute to do that one. What do you mean by crystal structure? Okay, so a crystal structure is basically the structure of a macromolecular or a giant structure. So the word crystal comes from the method used to figure out the structure of things. So it's called X-ray crystallography. So in terms of A-level, crystal structure just means the structure of. Okay, we're getting a slightly different answers there. So the correct answer to the question was a shared pair of electrons. So you were right in saying covalent, the ones that did say covalent, you were right in thinking that it's a covalent bond. But as the question said, state how they form bonds, you can't just say covalent bond, right? That doesn't answer the question. So you're asking like, how are they bonding? And the way that they're bonding is by sharing electrons. So be careful. What is a sigma? So a sigma is a single bond. Sigma bonds are single bonds. So be careful to sort of like always be answering the question rather than just writing down what you know about that topic. Sort of imagine, it's sometimes helpful to imagine you're explaining the answer to somebody that doesn't know anything about chemistry. Because if they ask you how it bonds, you wouldn't just say covalent, right? If they didn't know about chemistry, you would sort of explain about how they share electrons. So maybe if you were one of the people that said covalent, try to think of it that way. Okay, so the next question says, suggest why graphene does not conduct electricity. And so you have another minute, although I can see it, some of you have already started answering. I'll give you another minute to answer that. Ati, did that explain your answer, or do you have sort of like a, if it didn't explain your answer, could you let me know sort of what exactly you would like me to explain? Cool. I think we have enough answers in there. What is a lattice again? A lattice is anything where you have like things joined up, sort of like think of like a lattice apple pie. It's sort of when things are connected in a repeating pattern. Like anything that's sort of like this is a lattice. Sort of things joining up in repeating patterns. I feel like that's the best definition I can come up with. But let me find like the proper definition of the word lattice. An interlaced structure. That's the best way of putting it. Okay, so everybody that said it's because there are no delocalized electrons, that is correct. That's why graphene does not conduct electricity. So what is I'll come back to, there are covalent lattices. Yes, that is what graphene is, the thing that we're looking at. Everybody that mentioned graphene, be really careful. Graphene is a different thing. This question is asking about graphene. Graphene was discovered quite a bit before 2009. Yeah, so lattice, a regular arrangement is also a good way of explaining lattice. Who just asked me what a buckyball was? Somebody asked me what somebody asked me what a buckyball was. So Buckminster Fluorine, or a buckyball, is essentially a lattice of carbon, but in a ball shape. It kind of looks like a football. You know how like footballs have these like hexagonal ball shapes? Imagine that, but with a carbon at each point of the hexagon, and it sort of goes on and on and on around the ball. And I really can't draw a buckyball or Buckminster Fluorine because it's quite a difficult thing to draw. But have a Google. It's a lattice ball of carbon. Cool, perfect. So the last part of the question says, deduce the empirical formula of graphene. So not graphene again, graphene. Go for it. So if it helps, we can go back here and remember we've got this picture here, and it says that a carbon atom is bonded to 3 other carbon atoms and 1 hydrogen atom. So we want the empirical formula. We have a minute. What's the difference between graphene and graphene? So you know, if you remember graphite has hexagonal. Could I explain part C again? Yes, I can. Just give me 1 second, Tom, preach. So if you remember, our graphene is a single layer of graphite. And graphite has this similar structure to graphene, wherein it has this hexagonal structure, but there are delocalized electrons between each layer of graphite. There's no hydrogen bonded to the carbons in the same way as graphene. So we're less a carbon, we're less a hydrogen, and we do have some delocalized electrons. So graphene can conduct electricity. Okay, so, and I also had a question saying, could I explain C again? So graphene doesn't conduct electricity. If you notice in the question, it said each carbon atom is bonded to 3 other carbon atoms and 1 hydrogen, which means that each of our carbons is making 4 bonds, right? And if it's making 4 bonds, that's all of our electrons being used up. So there are no delocalized electrons. So there are no free electrons. And for something to conduct electricity, it must carry charge. And charge can only be carried with either electrons or some kind of ion. We don't have any ions or electrons, so it cannot conduct electricity. I hope that answers your question. Let me know if you have any other questions. Anyway, so empirical formula of graphene. So I'm going to go through it because we've had some dodginess. So remember, it said that each carbon atom is bonded to 3 other carbon atoms and 1 hydrogen atom. So that means per graphene bit, we have a carbon bonded to 1 hydrogen. So that means our empirical formula is going to end up just being CH. Can charge be carried by a positive ion? Yes, Mimi. So it should just be CH. Is graphene graphite then? So graphene is a single atom layer of graphite. So you know how graphite has lots of layers of that hexagonal carbon structure, and then in between the layers are electrons. Graphene is when you peel a single atom layer of that graphite off. That's graphene, and graphene has some really wicked properties that are being exploited at the moment by chemists. Graphene, which is the subject of this question, is different from graphene. Why is it just CH? Okay, let's go back to the image and we'll count, right? So if we look at every carbon on here, so I'm going to sort of dot every carbon in yellow. So every carbon here, yellow is not very strong. I'm not going to use yellow. I'm going to use blue or something instead. I'm going to dot every, it's just big. I'm going to dot every carbon in blue. And then I'm going to dot every hydrogen in green. Notice that every carbon has 1 hydrogen, right? And if every single carbon has 1 hydrogen, the empirical formula must therefore be 1 carbon per 1 hydrogen, so CH. Does that make sense? Is anybody else confused about why it's CH? Remember, an empirical formula is sort of like the simplest possible form of the formula. So of course, in this ring, we have like 1, 2, 3, 4, 5, 6 carbons, but each has a hydrogen. So we have also 6 hydrogens, and so on and so on. No matter how much bigger we get, we could have C100 and H100. But of course, that means the empirical formula must be CH. Yeah. So you disregard all the other carbons attached. It's not so much that you disregard them, it's just that an empirical formula is a ratio. You're asking what is the ratio between carbon and hydrogen, and the ratio is 1 to 1 in graphene. So graphene is different from graphite, yes, definitely. Graphite doesn't have these hydrogens in between layers, and graphite has many layers of hexagonal carbons. So what's the molecular formula? So you can't have a molecular formula for a giant structure like graphene or graphene, because technically it could go on forever. It could just go on and on and on and on and on and on and on. So you can't really write down the molecular formula in the same way as you can write down CO2, right? Isn't the ratio 3 to 1 though? Do you have 3 carbons for every hydrogen? If you try counting on the actual diagram. Do you have 3 carbons for every hydrogen? Because that would be a 3 to 1 ratio. Okay, can we not insult people on this forum, please? Even if they say something insulting, you don't want to say something insulting in response. So if we could all just avoid insulting each other, that would be really good. Yeah. Cool. I'm going to move forwards because we've sort of been on this one for a little while. All right. So fluorine forms compounds with many other elephants. Fluorine does not form compound with elephants. Many other elements. Fluorine reacts with bromine to form liquid bromine trifluoride, BRF3. State the type of bond between bromine and fluorine in BRF3 and state how the bond is formed. Eunice, it's not so much about saying the word, it's about calling people names. And I really shouldn't have to explain that to you if you're doing your A-levels, right? That calling people names is wrong. That's something you should have been taught a long time ago. Right. So I'm going to, get back to things. I'm being distracted by people insulting other people, which is not what we want in a web class, right, guys? So please just keep it nice. So we're looking for the type of bond between bromine and fluorine and how the bond is formed. And it's 2 marks. I'm gonna give you about 2 minutes. Yeah, if you're having trouble with the stream, always just refresh the page and then you should be all right. So we're looking for the type of bond and how the bond is formed. And Ashi, if you sort of show up late, the best thing to do, if I've already explained something, is to just watch the live stream again once it's finished. That way. Cool. So lots of you are getting the exact correct answer. So I'm just going to go ahead and fill it in. So we do have a covalent bond, and the bond is formed by a shared pair of electrons. So well done everybody that answered that. And note that this time most of us sort of were able to answer the type and the how, because in the previous question here it said state how two carbon atoms form the bond in the graphene, and quite a few of you said covalent. So here it sort of very explicitly asks for a type and how. So like watch out for the times where it just says how in future, sort of making sure you're answering the question, but well done. Cool, perfect. So question B says, two molecules of BrF3 react to form ions as shown in the following equation. So we have 2 moles of BrF3, and then we're making BrF2, which is positively charged, and BrF4, which is negatively charged. And the first part of this question says to draw the shape of BrF3 and predict its bond angle and include any lone pairs of electrons that influence the shape. So we want to draw it and come up with the bond angle. Will there be a live stream on half equations? If you want one, Lauren, then yes. Yes, we did actually do a live stream on half redox equations a little while ago. So if you want to rewatch that one, you can also do that. Just check on our YouTube channel under the past live streams bit. So we're not gonna, I obviously can't see you guys draw the shape of the BrF3, but if you tell me what the bond angle is and sort of name the shape, then we'll be all right. So are lots of people having trouble with the stream at the moment and getting that through quite a bit? Try refreshing the page. I was getting a bitrate error like a minute ago, but now the error is not there anymore. Can you, if you try to refresh the page, is that all right? It's not loading? Just won't work? Okay, hang on. Let me try. So you've got a video. Can you hear me? It's working again? So you can hear me, but you just can't see me? It seems okay? Sorry, guys, I don't know why that's happening. It's working again. All right, we'll just see how it goes. Do we have to draw a 3D shape? You tell me. It depends on the kind of shape, doesn't it? All right, just keep me updated as to how the stream is doing, and then I'll pause if we need me to pause. But yes, so obviously you guys can't draw the shape for me. So just tell me what shape it should be and give me a bond angle. Gone again? Am I still here? It's still pausing? I don't know why, because the Wi-Fi I'm using is fine. I'm not sure what's happening. How to remember bond angles and shapes easily. So basically, Lauren, can you hear me even if you can't see me? Is that right? No, you can't hear me. Oh dear. Okay. So it's frozen and nobody can hear me, or you can hear me and it's no longer frozen. It's not working. I don't know why it's not working. Okay, I'm going to try switching Wi-Fis. So you might lose me. You already lost me, so I suppose it's fine. I'm going to try a different Wi-Fi. If those who can hear me, so if you can hear me and you haven't lost me, I'm trying a different Wi-Fi. Let's see how that goes. All right. Can you hear me? Can you see and hear me now? Specifically now? Not working? Still not working. Oh. Just one of those days, isn't it? Trying another Wi-Fi. Okay, what about now? Yes, I can see it. Error again. Yeah, I'm going to try restarting the live stream. I don't think there's much of a choice. I'll be back. Okay, I'm being told that I'm back on, but my screen is not showing me back on, so just bear with me for just a minute. Just 1 second, sorry people. Tech. Aha! Okay. Can everybody see me? Am I back properly? Is it all good? No? Yes? Maybe? Hello? It's fine now? Okay, it's fine now. Good. Oh, okay, fine, fine. We are fine. So apparently YouTube is having troubles, not my internet. Probably lots more people are doing live streams than usual. We'll see if we can keep this going, but let's carry on. All right, so lots of you had already answered, so I'm just going to go ahead and finish answering this question. Okay, so what we should have had is a structure like this. So if you guys think about the fact that bromine has, obviously we have 8 spaces for electrons. What we should have is a bromine here with 4 fluorine, 3 fluorines, and then a show of electrons off of the side of bromine. So what we should have is a bond angle of 120 degrees. So you should have said trigonal planar. You could have said T-shaped. T-shaped was also accepted. So it could have looked like this. It could have looked like this with maybe like 84, or it could have looked like this with a trigonal planar 120 degree bond angle. So your T-shape can be anywhere between 84 and 90 degrees, anywhere between those. Have I frozen again? Can you guys see me? Because my live chat is frozen unless people just aren't saying anything. Am I frozen again? If I'm not frozen again, then I just can't see you.